What up, Calculus students? We have the last lesson of the first semester of the year, um, where we're still doing related rates problems, but we have triangles and angles. Just letting you know right off the bat that this first page, this is what it's going to look like on your test. This would be like a part C or D or E on free response question. And then after the first page, you will see questions like these on your midterm. There will be a train type problem or an angle type problem on your midterm. So good stuff. Um, Also, like the last couple problems on things that are involving the product rule, you will see on your midterm. Okay. So we got a particle moving along the coordinate plane, arrives at the point 4,3. It moves directly upward without any horizontal motion at a rate of 2 units per second. I am being nice, and I'm telling you, hey, dy dt is 2, whereas dx dt is 0. So it's moving up. Its y distance is increasing. Its x distance is neither increasing nor decreasing. How quickly is the distance between the origin and the particle changing at that moment? Well, we have to understand that points are x and y displacements. So this x distance is 4, this y distance is 3. We have this diagonal distance, and we've created a right triangle where the Pythagorean theorem kind of dominates the relationship between the side lengths and the hypotenuse and the distance. Okay. For a lot of these questions, we will need the change formula of the Pythagorean theorem, which starts out as 2x dx dt. This is taking the derivative of the Pythagorean theorem with respect to t, plus 2y dy dt equals 2d dd dt. However, we will see very quickly that the 2's can cancel. So we get this change equation that if you want to know how certain characteristics of this motion relate to each other in the diagonal relationship, you have this formula: x times how x is changing plus y length times how y is changing is equal to the diagonal distance d times how the distance is changing. We are looking for how this is changing. Okay, so we are looking for d dt. You need to be able to figure that out. How quickly is the distance between the origin and the particle changing at the moment? You need to realize, oh, we're talking about how this length d is changing. You were told dx dt is 0. Great. That means you don't need to use this point 4, that x is 4. You're told that this y distance is increasing by 2 units per second. So my particle's moving upward, and we would have that y is 3 and dy dt is 2. We don't have d. What are we going to do if we don't have d? Well, this is where we use the Pythagorean theorem to maybe find a missing piece of information. For example, we have this 0.43. So if we have 4 and 3, this diagonal distance, this kind of like radius, 16 plus 9 equals d squared. Oh yeah, this is a 3, 4, 5 right triangle. D is 5. So we get that d is 5, and now we get our answer that the distance is changing by 6/5 of a unit per second. That's how d is changing. Okay. Then we switch gears and we ask about the angle, how that angle is changing. Well, the formulas that have angles in them is in right triangles are trigonometric formulas. Sine theta, which would be y over d, cosine theta, which is x over d, and we got tangent of theta, which is y over x. Okay, SOHCAHTOA is what we're going to use. Now, here's the key. We need to pick the correct trig function that would be the most advantageous to use. We actually could use any 3 because we did find d dt, at this moment. So we really do have all three. We have dy dt, we have dx dt, and we have dd dt now, which means I could choose any of them. And I'll show you how any of them will work and you'll get the answer. But let's pretend we did not have this question. We did not do this question. We did not get that dd dt is 6/5. Instead, we have dx dt and dy dt. Because I'm given dx dt and dy dt, probably the most advantageous one to use is tangent. I'm going to use tangent because I have dx dt and dy dt given to me to start with. Again, since we have dd dt, you could have used any of them. Well, now we need the change equation. We need to figure out how this is changing as time is passing, which means we need to find the derivative of tangent. Now, the derivative of tangent, theta, would be secant squared theta. However, just like when we take the derivative of anything with respect to time, this is a variable. We need how that variable is changing. We need d theta dt. So tangent's derivative is secant squared theta d theta dt. Sine's derivative would be cosine theta d theta dt. Cosine's derivative would be negative sine theta d theta dt. And then we have the the quotient rule on the right side. The slopes of the top times the bottom minus the slopes of the bottom times the top, all over the bottom squared. Cool. Now we have information for the right-hand side. So I'm going to fill out the right-hand side. dy dt is 2 when x was 4. That's the x coordinate 4. We have that dx dt is 0. That's nice. We have that x is 4. So we got 4 squared here. So honestly, right away, I can drop a 4 and I can simplify this to be 1/2 on the right side. Now let's think about the secant squared of theta. Many people are like, I don't know how to do that, but it's not that bad. It's just the secant of theta squared. The secant of theta is the reciprocal of the cosine of theta. What's the cosine of theta? Well, the cosine of theta is just x over d. So the cosine of the theta in this situation is this x coordinate. This x coordinate was 4. Over the d, we found the d was 5. So we get cosine of the theta is 4/5, which means the secant of theta is 5/4, which means the secant squared theta is 5/4 squared, or 25/16. Don't forget your d theta dt. Now to solve for d theta dt, I'm going to multiply by the reciprocal. It's like the same as dividing by 25/16. I'm going to multiply by 16/25. So I have 1/2 times 16/25. And I get 8/25. It's a radian per second, not a units per second, but radians per second. The angle is increasing, which makes sense. Like, think about this particle moving upward. Since it is moving upward, this angle is going to be increasing. So things make sense. Okay. Cool. Same situation, just a little bit different. Again, this is very much like what you'd see for your test. Our particle, our dot, is probably moving along an implicit curve. And then I'm going to say the dot's going to stop here, and all of a sudden it's going to change directions. So it arrives on the point 1,3 in such a way that it starts moving downward and to the right. It moves downward at a rate of 2 units per second. Knowing that, I know my y distance is decreasing, and I'm telling you, and I'll do this for the test as well, that dy dt is -2. And to the right at a rate of 4 units per second. So since it's moving to the right, the x distance is increasing. Is the distance increasing or decreasing between the particle and the origin at that moment? By how much? So this is a great question because we get to this point and then we go down and to the right. So this y distance is going to be decreasing. This x distance is going to be increasing. It looks like it's moving to the right faster than it's moving down. So it looks like its distance is going to increase. But we don't know that for a fact. Why do we not know that for a fact? Well, because we see with the Pythagorean theorem that we don't just have dx dt and dy dt determining how the d dt is changing. You have the x position times how it's changing, the y position times how it's changing, and the d position, the d length, and how it's changing. Those all factor into play. So, again, I took the derivative and I canceled the 2's. I just did this all in one step. So hopefully you're comfortable with that. We have the point 1, 3. That's an x distance and y distance at this moment. We have the dx dt is 4. The dy dt is -2. I need to find the d. We're going to have to use the Pythagorean theorem. 1 squared plus 3 squared equals d squared. I get 9, 10 is d squared. So I get d is root 10. That's okay that we have a root. Don't worry, we don't have to have answers rationalized on a free response. And we notice something really quickly. We got 4 minus 6, which means we get -2 over root 10. We would think that since we're moving to the right quicker than we're moving downward, that my distance is increasing. But in fact, because we have this position here, my distance actually starts decreasing. My distance is decreasing at this moment. D is decreasing by 2 root 10 units per second. Here I should say D is increasing by 6/5 of a unit per second. Okay, again, it's just like how we had the statements of y's per x. We no longer are doing dy dx. The independent variable is time. Time is progressing, and we're seeing how things are changing at moments in time. So it's going to be y's per time, y's per t, x's per t. How's the angle of the elevation changing? Well, now we got an interesting situation where, like, since I'm moving down and to the right, it looks like my angle's got to be decreasing. So I'm thinking that I'm going to get a d theta dt that is negative. That's my instincts, but I'm not sure. So I'm just going to do the work. This one again, I don't have d d dt, and I probably should have gone back and showed you how if you had d d dt, well, you could use d d dt since you've already found it. But like, let's pretend we don't have d d dt and we're just looking at this as a new problem. We just have dy dt and dx dt. I'm also going to use tangent for this one. And just for this purpose, I'm going to also do just sine. Okay, I'll show you how you can get both answers. I think this is going to be easiest because it's with the values that I was given. So I get secant squared theta d theta dt equals dy dt x minus dx dt y all over x squared. Cool. Secant squared theta would be cosine theta flipped and squared. The cosine of theta would be 1 over root 10. I flip that and becomes root 10 over 1. I square it, it becomes 10. So that's actually another nice thing. That number works out so nicely. We got dy dt times x minus dx dt times y all over x squared. That's nice as well. I'll stay down here, and then I'll show you how you can get the same answer if you use sine. The only thing is, like, you would have needed to find d d dt. -2 minus 12 over 1, which is -14 over 10 after dividing by 10. Over 10, because that's 1 squared, which is 1. which is -7/2 or -3.5, my angle is decreasing as my particle is moving down and to the right. At this moment, this angle between the x-axis, the origin, and the particle, this angle will be decreasing. Makes sense, and it's cool that we got that answer. Let's see how we can get that answer using sine. I get cos theta d theta dt equals dy dt d minus dd dt y all over d squared. Okay, cool. Now this is easier because you have the cosine of theta. You don't have to worry about the secant squared theta. Cosine of theta is 1 over root 10. Cool. That's just the adjacent over the hypotenuse, x over t. We got dy dt is -2. We got d was root 10. We got dd dt, which we found, which was 2 over root 10 from the previous problem, times the y was 3, all over root 10 squared, which is 10. Now, this is even more of an indication why, yeah, pick the right trig function because you don't have to worry about roots. I get -2 root 10 minus 6 over root 10 over 10, which then I multiply by root 10 because I'm multiplying both sides by root 10. And when I multiply it by root 10, I get -2. I'm going to distribute it into the top because it's like root 10 over 1. I get -2 times root 10 times root 10 is 10, minus 6 over 10. That's -26 over 10. Divide. Why do I get a different answer? I shouldn't get a different answer unless I made a mistake here. Oh, d is -2 root 10. This should be a negative. That should be a negative, which means this becomes a plus, which means this becomes, I mean, this is like why, like, if you're confident what you're doing and you're doing everything correctly, it's like, it should be the same answer. I said d is decreasing by 2 root 10s, but that means d dt is -2 root 10. So that becomes a negative, that becomes a plus, that becomes -20 plus 6, which is -14 tenths. That doesn't work either. Oh, no, that's right. It's just this is wrong. Gross. Divide by 2. It's -7/5. Yeah, so like, hooray. If you have dx dt, dy dt, and dd dt, you can choose sine. It'll be easier. If you don't have how x is changing, how y is changing, and how d is changing, use the trig function that you do have, okay? And you will, you'll be good here. Okay, now we're going into more like word problems, not like particles in motion. So it's still Pythagorean theorem and trigonometry. We still have like an x, a y, a d. We want to know how d is changing. Is the distance between the two trains increasing or decreasing? It's kind of the same question that we had in class where it's like, it looks like since this is moving away faster than this is moving towards, that our distance is increasing, but turns out with diagonal distances, you need the positions to take into effect. So here's my Pythagorean theorem, and here's its change equation as time is progressing. We get x is 6. We get dx dt is 5. We get y is 8. But here's the key. dy dt is -4 because y is decreasing. It's almost like you should immediately at the beginning of the problem say, this is increasing, this is decreasing. Since that's decreasing, the derivative needs to be negative. We use the Pythagorean theorem with 6 and 8 to get that d is 10. And we will be able to find how the distance is changing. We have 30 plus -32 equals 10 d dt, and we realize that the distance is decreasing. I purposely give you that just so that you know that, rates of change are related to things. Doesn't have to just be the rate of change of the diagonal distance, just deals with the vertical and the horizontal distance. Why?
No, there's a quick question.
Oh yeah, let me just pause. Let me pause. Words. Talk lax coaching. Get back into it potentially for the future. I would like help out with the fall boys. Not really be on the full-time staff. I'm not ready to be on the full-time staff. When my kids get to middle school, then I'll be back to being ready. But how quickly is this angle right here between the station, the train to the east, and the train to the north changing? So this angle. So since I have d dt because I found it, we could go ahead and use any trig function. Go ahead and try it. I'm going to use tangent because I was given dy dt and dx dt. So I'm just going to use that and go from there. And yeah, we got just some stuff to plug in. And like, if you don't want to plug it in and you're like, I'm good, I understand. Like, sometimes doing the arithmetic takes the longest time. That's fine. It's fine as long as you know what you're doing. This is the angle. So we got x over d. So d over x, secant theta is d over x, which is 5/3, squared, which is 25/9. We got dy dt, which is, make sure you say it's -4x minus dx dt, which is, 5 times y all over x squared, which is 6 squared. Yeah, like this is gross, but like whatever. So don't stress about the arithmetic. Like for a free response, leave your answer like that. This is fine. Okay, for multiple choice, yeah, they never give you a problem that it involves too much arithmetic. So this is -64/36. Is that 2? No. That's 74, 72/36. Ugh. So I can divide the top and bottom by 9. That becomes a 4. I can divide by 2 and then 2 again. So 64 goes to 32, goes to 16. So I think I got -16/25. I could be wrong. I'm not gonna stress out about it. Okay, now we have a different situation. This airplane, where we're told the diagonal distance is decreasing. We have a diagonal distance. We say the airplane is flying horizontally 3 kilometers in the air. So we see that d is changing. We see that x is changing. And that's what I'm trying to find. Trying to find how quickly it's moving to the right. So I'm trying to find dx dt. So the question is, how is x changing? dy dt is 0 because y is not changing. Since it's not changing, its derivative is 0. So we know that this is going to be a 3, 4, 5 right triangle. We have our Pythagorean theorem to help us with that. We have the change equation of our Pythagorean theorem. This is how the x, y, and d, their changes are related to each other. We have 4 times dx dt, which I'm trying to find. We have 3 times 0, because the y distance is not changing. We have 5 times d dt is negative 400. Now, sometimes you don't pay attention to that. You can think about how if this plane is flying towards the radar station, how the x distance is decreasing. It does ask for speed. So, like, honestly, a positive or negative answer for this situation, I wouldn't care about. We'd get divided by 4, 500 kilometers per hour. Now, you should get a negative value, negative 500, but speed, we'll talk about more in the second semester, is just velocity without direction. So you'd say 500 kilometers per hour. So we just positive answers. Okay, angle of elevation. Now is the time where, yes, I have dx dt. Yes, I have dx dt, dy dt, and dd dt. I can choose whatever trig function, but I'm going to choose to use this one and this one because they were given to me. So I have my y and my dd dt, which equals negative 400. Y and d, I'm going to pick sine. I'm definitely, whichever one I pick, I want to use the fact that dy dt is 0. It'll just make my calculation so much easier, but doesn't have to be done. Just will make it easier. So I get cos theta d theta dt equals dy dt d minus dd dt y over d squared. Cos theta is adjacent over hypotenuse. Cos theta is 4/5. I have 0 minus dd dt y over d squared. So I get d theta dt equals negative 400 times 3 over 5 squared times 5 over 4. I'm leaving that if I can. Things do cancel nicely. This 4 turns into a 100. So I have negative 300 over 5, which is negative 60. I don't like that it's negative. Why is it negative? I would think that the angle is increasing as the plane is getting closer to me. Because I made another mistake. d dt is negative 400. So this is like one of those things where you're just like kind of thinking, and you're like, oh yeah, positive, positive, positive. 60 rads per second is pretty, it must be really close to us. I guess when it's 4 kilometers away, but it's traveling at 500 kilometers per hour, like it's going to go quickly through us. The radians are going to really change. Like the angle is going to change very quickly. 60 rads per second is intense, though. But whatever, I don't even know if this is accurate stuff I used. All right, on to page 3, same deal. Now you can tell this stuff is like tricky. All right, we're trying to find dx dt. I have that this ladder, and this is very similar to the problem we did in class. This ladder is not changing, so d dt is 0. I'm going to go straight to knowing that this is a 6, 8, 10 right triangle using the Pythagorean theorem, and straight to the change equation for horizontal, vertical, and diagonal distances. Something I'm not memorizing, guys, something I can produce knowing we have a right triangle and taking the derivative and dividing by 2. You're not memorizing stuff, you're understanding stuff. The y distance is decreasing because the ladder is moving downward. The y distance is decreasing. I put dy dt is negative 10 times 0. So dx dt will equal 12 eighths. The x distance is increasing. So we get 3 halves of a meter per second. Okay, another angle. I want to use the fact that d dt is 0. Yes, I have dx dt, but I'm going to use dy dt and d dt. So I'm going to use sine so that I have dy dt and dt. Sine theta equals y over d. So cos theta d theta dt equals dy dt d minus dd dt y over d squared. So cool how like this is how angles are changing. It's relative to a ratio of your side lengths and then how all of these lengths are changing in this quotient rule deal. Anyways, cos theta is 8 over 10, so that's 4/5 again. I usually give you numbers that work out. Actually, I didn't at the front page. Dy dt was, I expect d theta dt to be negative because I think my angle is going to be decreasing. So I pay attention to the fact that dy dt is negative 2. D is 10. D dt is a big fat 0. That is helpful to me doing my calculations. I have 10 squared. I can cancel one of these 10s. I get d theta dt is equal to negative 1/5 times 5/4. And I think this is the exact same question we had in class. So theta is decreasing. The last 3 questions, I guess, just have you remember, just like we're using the quotient rule, remember the product rule. A lot of times when we have a different situation, we have this cone, we forget that when we're taking the derivative and getting the change equation of the cone, that you have to use the product rule. Whether you leave out the 1/3 pi or you bake it in, it's up to you. But like, don't forget the product rule. All of this information is just height of the cone decreasing. Okay, dHdt is negative 2. Radius is decreasing. Okay, so drdt is negative 5. The radius is 100 centimeters. The height is 50. Let's say this is a free response question, which it was in 2022. This is a free response question. Guess what? I'm leaving my answer as 2 times 100 times negative 5 times 50 plus negative 2 times 100 squared. Done, 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 done. I know you don't believe me, you don't feel comfortable. And I know some students actually resort to, so they don't have to think, they just like do arithmetic a lot. They don't want to move to the next question because they're like, well, I don't feel comfortable with this. Might as well do some arithmetic. But it's like, don't. This is an answer. You can provide this answer. So I'm providing that answer because I don't want to do it. Now, one thing which I tried to mention in class, but we didn't get to it, is that if you have a relationship between things, you could use it right off the bat, or you need to understand that the height of the pile is always half of the radius of the pile. That means you have a relationship between the height and the radius. when the height is 10 feet, the radius must be 5, and like you gotta just make sure you understand to use the product rule. Don't forget about the product rule, and don't forget about relationships of one formula to another one. In the first day of related rates, we just had like the volume of a sphere. We didn't have to worry about product rule. But then we'd have the surface area that would incorporate it. So dV/dt is 100. I want to find how dH/dt is changing, which means, watch what I'm going to do, and many of you probably aren't doing this. Wherever I see dr/dt, I'm replacing it with 2 dH/dt. So I got 1/3 pi, I got 2 times r times dr/dt is 2 dH/dt. H is 10. This is just like a lot of stuff. dH/dt, r is 5. 5. So I have 100. I have 225 dH/dt's. I have 300 over 225 pi's as dH/dt. I just multiply by 3, divide by pi, and divide by 225. Did we have to use that? We actually could have understood that the volume of this sand pile with this relationship, we could have plugged in 2h for r. That way we would not have to worry about the product rule, but I'm going to want you to worry about the product rule because it's been showing up more and more on the AP exam. Letting you know right now, like this is just reminder problems versus problems that you will see for your tests. Problems you're going to see for your tests. First page are very much problems you'll see on your test. Second page / third page is your midterm. Yeah, so again, I'm just reminding you guys, product rule. Don't forget about the product rule. Okay. After 4 days, the height and the radius of the cylinder is measured to be 7 and 3. So the height is 7, the radius is 3. Respectively, growing at a rate of 3 feet per day. So this is the change in the height, and radius is changing at 2 feet per day. Cool. What is the volume of cubic aliens? Cubic feet of aliens. I made this question. Just wanted to make sure you guys remember the product rule for the last couple questions. Because we did the quotient rule, but we hadn't seen much product rule in this unit. So 2 times 3 times 2 times 7 plus 3 times 9 pi cubic feet per day. Okay, at this day. All right, this is tricky stuff. I've done it a lot, so hopefully you guys are actually trying. And in preparation for your test and your midterm, front page for your test, and then review second, third page for your midterm. Cool. I'm gonna have one of each for your quiz next class. All right. Peace.